Okay, so my random number generating program picked Kwong to go first. Are you okay with that? He's ready. He's been thinking about this a lot. I'm excited to hear his presentation. Joe has Visual Studio 2019 open. If you want to leave it open, other than that, you can do anything.
Yeah, there. You have to go out and go there.
You might have to unshare mine if it's not. I didn't share that.
Yeah, I got you. Who did you? Request on find yourself or go get that in you have to stop sharing your screen. You have to stop sharing.
Okay.
You see it?
Yeah.
I'm trying to see that soon. Yeah, which one?
There's a real thing. That little red stop share button.
Pop up somewhere that says you take control.
Yeah. Don't see it. Shiny. Right.
There you go.
Okay, it's automatic.
Now, here's our other button.
I like my lapse. It doesn't acknowledge me, it just laughs.
There we go. Now you can see it and we can see it and are you still seeing his screen? All right.
Is that fine? Right. Hi. My name is Kwong, and today I'm going to talk about artificial neural network. So, first, what is an artificial neural network? We probably hear people talking about AI or machine learning, and actually this is how it relates to each other. So artificial intelligence is like so artificial intelligence is kind of the biggest thing that contains everything else. So, and machine learning is one kind of artificial intelligence which are learn and then train based on the data given. And deep learning is one kind of machine learning. So where is neural network learning? It's kind of in between deep learning and machine learning because they both use neural network. I would say it's a basic structure, and it's kind of interchangeable. So neural network is kind of trying to emulate our human neural network. So in our human network, we got this, like our body contains like thousands of this or millions of billions of this. So these dendrites take, I would say, input that we receive from environment, and this cell body will handle the data and transmit here and give output, which is our brain to recognize things that happen around us. So it's going to be the same with the neural network. So it will the neural network will be made up like millions of this, not millions. It depends on the size of the network. But here, these are inputs, these are neurons, and these output. So, okay, so first, so you can see like this is input, and this is like, I would say this is the cell body, which neuron, or some of the programmer call them nodes or perception. They're the same. So what it does is it takes the input, like 100 or millions, and then multiply them with the weight, and then they do something else and give only one single output. So let's get into the vocabulary. So ways is define how important inputs are. So which means, for example, if we see a dog, so based on the characteristic of the dog, we're gonna have different way. For example, like if it's a dog, 4 legs and small with tails, will have like bigger weight, so it affects more than the other aspect of the dog. Bias is one thing that allows you to that one. I think I'm gonna talk about this later. Okay, maybe, yeah. So how it works. So first it takes input that are given. So I'm gonna specifically talk about how a neural network can recognize our handwritings. So basically it just, the network contains of 3 main things, I would say components. First are inputs. Second are gonna be hidden layers. It's hidden because it could be many layers. And it depends on how precisely we want the output is, and the final part will be output. So it takes input, multiple inputs, and then you're gonna have hidden layers. So I would say, for example, just one layer, each of these nodes will take input from all of these and do some calculator and give only one output. Just eventually we only want to know what it is they're recognizing. So for example, I'm going to talk about how we recognize handwriting. So imagine if you got a picture of a number 3, and then each of these will be a pixel, and each of the pixel will contain number from 0 to 1, represent the grayscale of that pixel. So like you see, like the main part will have like higher grayscale, which is white, and like it's dimmer and it's dark when there's nothing around it. So you imagine you're gonna have to like put them in one array, like left to right, up to down, like that, and then it has to recognize what number it is. So this is how they're gonna like put all the pixels in one array. And here are the outputs. So these are the hidden layers. It could be like 2 or 3 or 5, depends on the programmer. And eventually they're gonna only give one output, which is number 7. That's that we want it to be here. So I already talked about each of the pixel about. So each of them they also call activation. So this will be a same with neuron or nodes. So an activation holds a number. Each of activation only holds a number after it calculate and give output. Here I already talked about hidden layers. And why do we need a lot of hidden layers? So for example, number 9, how we recognize number 9. we'll tell the computer or program them to, for example, there will be a loop and a line, and in the loop, it could be an A, and like that. So that's why it has to have a lot of numbers to see which one weigh more, and to be able to recognize that, for example, the last layer, because it's a number 9, right? It will recognize this. And maybe you recognize this part right here with higher weight. So eventually it'll point to this one. But why do we need, so if it, why does it not go straight from here and here to there? Why do we need a bunch of hidden layers? Because we need them because, for example, on one single loop that we got here is made of different kind of curve. So that's why we need more layer to only recognize that loop, and you'll do the same thing. You like each of the nodes will have a mission to recognize if it's this one or that one or that one. So each of these will be one activation. And what does one activation do? Or see, they can call node or a single neuron do. So I already tell you that these will be input, right? And each of the nodes will connect to all of the inputs. So they got different ways. W stand for ways, and based on what the correct characteristic, the way will be higher or lower, depends on how important that data to that number 7, for example. So they'll, for example, to get this value of grayscale, and depends on how important it is, multiply with them, way 2, and they just basically multiply each of these with each of their own ways and add them up together. Here is the diagram. So you're gonna have, it looks kind of complicated, but basically you're gonna multiply this, each of the input value with x1 with their ways, and then add them up together. And eventually you're gonna have to add up with bias, which is gonna be like whenever we got like bite or sting by a bee, depends on how hard it is. Our body will tell us. If it's not noticeable, it won't tell us. That's why we need bias to like tell us what range we want to calculate it. And eventually they're gonna plot all of that number to a function called, there are a lot of functions, but for the example that I'm watching on YouTube, they only use sigmoids. But the other function is kind of, you can see from the graph, they will take like arbitrarily inputs and only give output in a range of 0 and 1. That's how they only give us one kind of, I would say that's how they only give us one output, even though they take a bunch of inputs. And for these, it kind of makes sense, like because computer only understands 0 or 1. That's why, like through a bunch of layers, this will like narrow down to just 1 or 0. And so this is just basically they're just use this one, multiply by the way, add this one. The input one, A1, multiply by the ways. They just add them up together and they add bias at the end. And why do we use C#? Because C#, they support these. So this is how we write handwriting, but like we can use notation as the vector products with the matrix. And C# support that with their .NET library framework, and that's why we can benefit that from C#. And some people still use C# to do neural networks. Here is the all of the I would say function and support to calculate all of those. So, and at the end, so for I would say the first run, so basically all of the weights initially is set by programmer, and it looks like it is the programmer program everything, but it's not, because like usually the first result is supposed to be this one. It's gonna be white, and all of the others should be dark. But like for the first one, like it kind of cannot recognize what the number is. But we also have like I would say a model map. So it would say you can have 3, and you know it's 3 because our brain can recognize 3. So we make this one and compare to the actual value. And they call the cost function. So this is how they calculate cost function. They basically just subtract these and add them up together and square them to make it just positive and add them up together. So you can see the bigger the cost is, and the more, I would say, the more wrong the neural network, the more inefficient efficiency the network is. So they have to somehow adjust themselves to make the cost lower. So this is how it looks like. So whenever you got a cost, and basically the program itself adjusts. We cannot adjust the activation because that is fixed. We set it up, but we can affect them through adjusting the bias and weight. So imagine like whenever you adjust the weight here, at the end, the cost will adjust like accordingly, just like functions. So like whenever X change, Y will change, and depends on the range. If like, for example, if we change this like here, we nudge it around here. If it nudge around like the center, I would say, so it will help you to define how much change here affect the final output. So this is how. There are 3 ways to adjust each of the activation is through increasing the bias or the weights. And all of these changing will eventually change the input. So, and this is kind of about calculus. So we eventually want to change the final result. That just, for example, number 9. So only number 9 lights up, and the other has to be darker. So this one can be changed by changing the weight bias from this one. And we use the rate of change, like how much this one changed, make this one change. And this one changed because of this one change. So it keep affect each other. It's kind of composition functions. If any of you take calculus, so basically to find like the change between the beginning and the end, you have to find the change between each of the layers and multiply them together. That is the, I would say, the easiest to understand them. But like if you actually watch the video, it will be easier than what I'm talking, because they got like animation. And so why do we choose C#? Like I said, because it's free, and you got a .NET framework which support some like most of the calculation for the network. And they also got the ML.NET framework, which is open source and also support on like text data and get trained with the data, and it's object oriented. And thank you for not sleeping. I know I confused you guys a lot. Yeah. Do you have any questions? Yeah. You also got this one if you want to see how it actually looked like. There's some of the YouTube video so the YouTube video that I found is actually about a programmer writing a neural network to train the snake to play the snake game, and they also got a link of the source code that written and post on GitHub. If you're interested in it, you can just. I think you should look for the neural network learns to play snake, and you'll find it. There will be a link to the source code. Thank you. You have any questions?
Explain any of that to you.
Honestly, I don't expect you guys to like. Yeah, because I was kind of learning that like every day since the last week. So like each of every night I just watch random videos about that and like look up math stuff. I hope I gonna have another chance.
Having software that has like artificial intelligence capability.
I'm not sure, but like actually,
Selling things.
yeah, like but actually we're using them like our Google in series and car like her car or using artificial intelligence or neural network, but it's just like the way it gets better is to be trained, and the manufacturer don't let them train with us. They train them before they give us the product. That's why it looks like program, but actually it uses neural network. Yeah.
So sometimes my car makes a wrong decision based on its bias. But it's hard stuff though. Think about with car programming. I mean, some of the stuff is,
Yeah.
you know, if you see a motorcycle in another car, which one has the higher weight? You know, all of that has to be taken into consideration. You know, when they're programming those kinds of things.
Yeah,
So,
like they got the input data and the model output. So I'm thinking like whenever we have to do capture, whenever we go into website, like I think they actually make us to make data for them to train their AI.
So like when they actually get it up and going and learning, does it kind of become like, does the program kind of become a black box in which it's very hard to manually edit it if you want to?
You still can edit it. You still can edit it, but I don't know if it can evolve that way. But like,
it's the intelligence of the output that's changing, not the code itself.
so like
So the data that you're reading in is going to be more intelligent than the data that you're reading in before the program was learning. Does that make sense?
Yeah, it makes
And your output's going to be more intelligent. But the program itself, code-wise, isn't going to
Yeah.
change unless
So-
you change it.
So you could see like the first result of the program will be arbitrarily. It won't close to what we desired, we want it to be. That's why they got a model and they calculate the cost. The bigger cost is the bad, I would say the worst program is, and they have to adjust them through using derivative and change rules. Like talking about derivative, you may remember the slope. So to find the lowest point of the graph, the slope has to be 0. And that's how they use derivative and stuff. And like before I watching this, I just realized I kind of just gave up on some part of calculus when they were in the class, but at least I can let you guys know like we still can apply those math that we thought that we never used them. I thought I never used them until I saw these videos.
Thank you.
Thank you. Sorry, Gray.
He has to share it first. Share your screen first. And on the top right, there should be a little mouse. Yeah. No, there should be a little mouse. Yeah, and then just over there. Yeah. And then you have to accept it on there, I believe. But
Okay, so I did API application in C#. So what is an API? API stands for Application Programming Interface. And this pretty much allows software to interact with each other and also for users to interact with software through different interfaces. I watched a video that explained it in a really good way because the dictionary definition kind of sucks just because it's so formal. It explained it as your waiter or waitress at a restaurant. So if you're sitting down at a table at a restaurant, you're not just going to walk into the back and be like, hey, I want a burger. You have to sit down at your table and wait for your waiter or waitress to come, which is the API. And you have to give them your order, which would be your request for data. And then they would go to the back to the database or the kitchen and get that data for you. And you would get it. So why is this important? It allows for the standardization and simplification of data. So whenever you get data from a database, it kind of organizes it and puts it into a clean-cut set of information for you. And like I said earlier, it allows software to communicate with each other and communicate with you so you can actually get it and see it in a readable form. So the types of APIs, I'm not going to go in depth on all the types. Really, it's just there's main web APIs and web service APIs. The main web ones are really different based on your permissions. And then the web service APIs, those are the ones that we're most familiar with, because I'm sure you guys recognize XML, because we did that in here. And then JSON, if you guys took Web Dev 2, which I know you'll probably all have to, we mess with JSON files in there as well. So in C#, we just use this to get information from databases. So more specifically, I took an example from YouTube. There's a ton of examples that are like hours long about how to get these API keys from websites and whatnot and actually apply them. And I just took the shortest one I could find so that I could actually fit it into a presentation. And I put it into a short 6-step process. So essentially, you'll just create a Windows form, add a button, and a data grid view. You'll have to add in the using system, .NET.HTTP, and then same thing with dot formatting in there. You'll add this code to your button, which will, you just have to add in the URL and the API key. And then that will load the information from the API key into your data grid view. And it's really simple and straightforward. We're all familiar with the XML files. This is what they look like. I mean, we've all seen it before. So we'll also have to create our API base class. So you take all of these labels and create variables for each of them. and that will add all of our data into the data grid view, and it puts it into a readable form for us to be able to use. So in conclusion, APIs can be used to communicate with clients to gather data, and we can actually use that in our projects and just in all of our applications. Like a lot of the stuff for it was mostly web development based, so it was very hard for me to find C# applications, which, yeah, that made it very difficult for this project. But yeah. This part?
Tell everybody what's going on there.
So I know that it is opening up the HTTP client, and we're feeding that the URL to so that it knows where we're getting the API from. And then whenever we open up the response message, that's saying that it's opening up the API and saying, hey, I'm going to send you an API. Here's the key for it. And then the EMP variable is actually looking at this base class and is filling that information in based off of what is in this XML file. So it's going through each of these variables and filling in each of those labels, and then it's putting that into the data grid view. Yeah. So that is my presentation.
Good questions? I'm going to ask him a few questions and help him out on his time. They're not going to help you out.
That's okay.
Let's see how they are.
I got one for you.
There you
Let me
go.
think of something real quick.
Good job.
What made you? You said you've taken the web dev class as well.
Yeah.
Do you think I think it's easier to do the JSON one, or a little more difficult to do the JSON one than the XML one. It's like a little easier to use. Which one do you prefer? Or have you used any of the other ones besides this?
I actually kind of prefer using the JSON one just because it felt easier to do or not easier, but it felt just like it made more sense in the web dev class. I actually don't remember all the step-by-step processes in the web dev class whenever we did it, but I don't know why JavaScript made so much more sense to me than C# does.
So, like, in your research of APIs, do you come across any tools that could make it easier for a programmer? Like, I know you could probably manually, get data from a file or something like that, but say you're working with more complicated data than just an XML file, is there applications you could use or plugins to Visual Studios?
On a couple of the YouTube examples I was looking at, there were a bunch of packages that Visual Studio provided that they were downloading at the start, but I didn't look into exactly what those did or what they were called. I just saw that they did use those, so I'm not really sure. Yeah.
Good job. Good job. He's got enough time.
Okay. Thank you, guys.
Yeah. Can you do a quick comparison between APIs and framework? I'm not sure if they're the same to compare. I kind of usually confuse between API and framework.
I actually really don't know.
It's like
Because-
it's like he said the API is the waiter and waitress. The framework is the kitchen.
Okay.
Yeah, because the waiter and the waitress have to go back to the kitchen to get the products that are available at that restaurant. That's the framework.
Yeah.
Okay, and then the waiter and the waitress are utilizing the framework to supply you, the API user, with the product offered by the API. That makes sense. Your menu. I lost in there. Sounds good. We'll actually be starting on creating a web-based API for others to gather data from and next stuff that we do. So that'll be yeah, thanks. So it's a good lead-in. You tell me some stuff. Okay, I have a request from Clint to go next. So, Michael, is that all right with you?
Sure.
I figured you would be okay with it. It's not a problem. Shoot, you're fine.
You could pick that back. We do all those same things. Well, one of them's already white. But change my code does everything. Who is playing Dota?
So So I guess every one of you knows how when you want something, a product online, then before you buy it, you always have to review, go to the review section, and they always have this statistics or statistics or predictions of people liking that product. And now I'm going to present to you what machine learning do and how it does, how it connects with those examples that I have given. So I'm going to present to you machine learning using C# ML.NET framework in making a sentiment analysis console program.
Did you give it control?
Oh, I did not. I'm just gonna do it.
No, you just there's a request that you can there. You should be able to convert it to request control.
Okay.
Click something.
Try to click on her computer first. So I'm going to do it back. So if you ever notice those details on the the review section of every website or e-commerce websites, those all have to do with machine learning. So what really is machine learning? According to the book written by, according to the book of Practical Machine Learning is another way of problem solving using a platform. It is also a mechanism for pattern search, and machine learning is a subset of artificial intelligence. So with machine learning do is they feed them with data and learn from those data every single time every single input or data that it collects. So this is what machine learning do, especially in video. Yeah, so without machine learning, it only does like the the very specific instructions like we code right now. Like every single line the computer will have to follow, but instead with the machine learning, we just feed them with a bunch of data. We can also code along the way. We can also use those data to make predictions. So what machine learning do is collects the data, it cleanses and sorts out data, it processes the data, and using algorithms to learn those data. Like regression algorithm, I don't know that much about that yet, but they use like tons of algorithms to sort out those data, and they make predictions. So what are the goals of machine learning? The goals of machine learning are those they can make the data, predicts the data with accuracy and speed and time. They always wanted, from example companies like Netflix, they always do like machine learning because they just feed the data. They just make the company feeds the data from the machine learning to the machine learning, and then the machine learning learns those data and outputs those data then better than people who will write every single coding and consumes a lot of time. So basically, machine learning is very effective at speed and time, and also from of money. So I'm going to do right now in a little bit is creating a console program, which is a sentiment analysis console program, which is which use ML.NET framework. So what is sentiment analysis? So sentiment analysis is a natural language processing and text analysis. All those what you post on Facebook, what you put in reviews on the products like Amazon and Best Buy or whatever you like on an e-commerce website or a social media. It processes those word for word, and machine learning they will read the lines word for word, and what they do is predict if for example, I don't like it, it's a negative. That's their analysis. And if you say it's tolerable, it's going to be a neutral. And you say the product is wonderful, it's going to be a positive. So that is a brief definition of sentiment analysis. So how does it use in C#? What is it using to us .NET developers? So Microsoft created ML.NET framework for us to be still using the .NET ecosystem. So what is ML.NET? Like Juan already explained a bit earlier. So ML.NET is an open source and cross-platform machine learning framework. It's an open source. Everybody can jump in, edit, make some changes, and it's a cross-platform. It can be used in Mac OS, Linux, and Windows, of course. And ML.NET also can create custom ML models using .NET ecosystem, so we don't have to find another language to be able to use machine learning. But we always have like other programming languages that are very popular right now, like Python. But ML.NET and Visual Studio, they support all of them. So it's very easy also to integrate into projects like web, mobile, desktop, and gaming and IoT apps. So I'm going to explain to you how the workflow of ML.NET framework. So
as you can see, it has a build model. It loops every single time. So every time that you created feed them to the data, it collects you as a user or a programmer. You feed them the data, and the framework collects and loads the data. It creates a pipeline. It stores the data, and it trains, and the program trains itself, and it trains itself from the data and improve the machine to make it more, or evaluate those data and make them as accurate as possible. And when it does trains itself, it will save a model, which is all the collective data, all the collective predictions, and you can use those model, and you have to load the model and eventually use it to your program to make predictions. Now I'm going to show you an example. It's a very, very, very short example of how to use ML.NET. Give me a second. I'm gonna have to bring up my computer. Okay. So this is the example. You actually have to download the extension file, and then it have it on the, oops. Oops, I don't want to see that. That was the data coming from the Wikipedia, all those reviews and comments. So what you do is go to your, if you make a console program for it or whatever programs that you made, and you have to add and click this machine learning. And right now I'm doing a sentiment analysis, which a sentiment analysis, it's a binary classifications. It outputs or predicts a 1 or 0 based on those text files, or based on those data, and predict them if they are toxic or not. So I build a scenario. It says sentiment analysis, file, and I will select a file. This one right here. And all those sentiments right here is 1s or 0s. And then predict column, the sentiment text. And then you have to train and start training. But that takes like 10 seconds to train. So I already made a program for that, for you to look for. So this is what, after it trains and evaluates and adds the code, it creates this model right here. It's a model builder right here. All those classes over here, which you have to make, and I'll explain it in a little bit. So here's your program. Pretend that this is your program or your console program. I have the string data file loaded right here. And on my main method, I put a string input sentiment, and it goes in a loop, you know, and enter sentiment and reads the line, and have this var input. It creates a new instance of a model input. So you would say input the getters and setters name, a sentiment text equals the input sentiment, and then you also have to make an instance of the model output, and then you put that input data from the consume model class in the predict method. So I have, and then I'll put them in a console write line, and we can see, and we can also get the prediction. So let's run it. Okay. So we could say enter sentiment. So we could say, I really like it says, oops. Well, sometimes machine sentiment analysis also have a problem with sarcasm. So that's sometimes why it says the output says is toxic, it equals to true, which is some of them are not, or some of them were. Okay, let's try. I don't
say you like something, but you don't like it.
It's I feel like the example data are very limited, and some of the data are the time that I was making this this project was, it only has 66% of accuracy, so that's probably why. So I have to go and find some more big files or big data for me to train and you know, train the machine, or train the code, and which is why ML.NET framework it all does it for you in the background. So it's pretty amazing. It's very easy to use. So let's add another one. See, it's when it outputs it outputs you if it is toxic or not. It says false. It just means the sentiment or the text is not toxic. So pretty much that's my example for here, and we'll go back to mine. So that's how it works. So I think every one of you already know what machine learning could do. It has various application you could use for using machine learning, just like face recognition on your phones, on your thumbprint, touch ID, whatever that is. And also, this is a picture or the sensors from a Tesla car. It makes predictions of car, which also they have tutorials in Microsoft.NET. If you just look for ML.NET framework, they have a tutorial of objects they could predict. If it's a dog or a cat or a person or a table, it's a lot. It's very, very broad. And also, this is the ad that I get from my Facebook, because for some reason my car broke down and I had to research for cars and came across with a Silverado who's $10,000 to $15,000, and then output it gives me an ad, which does with machine learning that social medias do. So
Awesome. Okay. That sounds great. Give him a hand.
You got a question?
Question. Yeah.
Mm.
So, you know how it took about 10 seconds for the
Yes.
machine learning to
Yes.
kind of get proper? Does it matter how long you? I mean, like obviously there's like a minimum amount of time it takes.
There's no minimum. It depends on how big is your data. And I've heard from those developers from Microsoft that it could take days or weeks if to train those data from your for your project. So if you have like big data from your SQL that the machine learning has to read them and process them, train themselves and learn themselves to make predictions for you to use the program. It would take from seconds to days to weeks.
So, but it loops through the data multiple times to
Say that again.
oh, it loops through the data multiple times to get better and better.
It all does. The .NET framework always does it for you on the background, and I think that it will all loops every single time you add them with data, and when it collects more data, it loops by itself. It learns, it processes, it cleans and sorts out all those data and improves itself and have those make best accuracy from those data. So that's how machine learning does. Any questions?
The algorithm you mentioned.
Yeah.
Like you say sometimes, do you think it would be neural network related?
Some, I haven't been looking into neural network, but AI, and machine learning is a subset of AI. It's the same as deep learning. And deep learning also has this algorithm that uses neural network. It's pretty much the same as, I would say, artificial intelligence follows code. And then when the artificial intelligence learns from those data, it becomes machine learning. And then machine learning, it will use more deeper, more complicated data that needs to be processed. It will be said deep learning, and that is when neural network comes to use. It all makes predictions and stuff like that. So I would say like Tesla cars, they always use, I think they use neural network to process all those data, which lanes can be used if what's in front of you, a police car or a motorcycle in the lane that has a cone with it, I know that it processes all those data. Did I answer your question?
Yeah. Okay, so would you be using neural learning or machine learning? Like I saw an example online. Like you see the game with the little bird jumps up and down with Mario 2.
Yeah.
Yeah. Bird.
It's a blackbird.
Yeah.
Um,
What would you be using? You could get it to complete the game. Like I saw the example of like a bunch of birds. One will die, and the next one will pass where that one went. You know what I'm saying?
I think if you're talking about a game, I think it all depends on what really you want to use, because you can always set like you randomize everything, and you can always use specific instructions. You can also use machine learning. I think you can always use machine learning if you set your words to use by themselves. I like to act by themselves. So it's, let's say you run the program, you put the words as let's say the words are the machine and it learns by itself. So it has these obstacles, and then it will jump itself just not to hit those obstacles that it will pass, and then it keeps learning, and then for the long period of time it collects the data and how not to bump all those obstacles, and is when you use machine learning. It always does for himself and not you. It's not you pressing all those space and then make them jump just not to grade. And machine learning does it by itself. Yeah, I think that's what machine learning is.
If you watch the video of the snake, they got explanation like the snake will have 8 directions, and they are looking for food, and they are looking for more and for themselves, and how they train get better and between each generation. And like I forgot to mention, but the key things about self-learning, I would call, is back propagation. They use the cost function, and they trade back to the beginning to like adjust themselves to find the minimum value they can adjust to have the lowest cost. and get better.
Yeah, your example made me think of that. When I saw the video, the snake one.
Yeah, they got 8 direction. They got explanation on the project on GitHub.
So any questions, everyone?
Great one. Good job. Yay.
Thank you.
Okay, Michael, we're gonna go to them.
All right, well, my topic is not as advanced as that, but I'm going to give you the basic understanding of Unity and how to use C# to create games. The building blocks of Unity, you have game objects, you give components to those game objects, and you write scripts to make it do what it wants. The game I built was like a simple break blocking game. Everything you see in the screen is a game object. So each block, the camera, the ball, the paddle, everything considered a game object. And then you give each object a component. Automatically, each object gives a transform component, the position on the screen. And then, for example, on my paddle, I gave it a rigid body, so it knows like when stuff collides with it, something will happen. And then then you can give it a script. But before you mess with scripts, you gotta have understanding of mono behavior. Mono behavior is a base class from which every Unity script derives from. And you need to use it to get access to the variables of each of the components. Here's an example script of my block. Very simple. When something collides with it, it's destroyed. You see that I'm using the base class mono behavior there, and it has a function on collision that you can call. And let's see. Here's a little more advanced script that I wrote for my paddle. Once again, use mono behavior. I gave them parameters. It's hard to explain. This is a mono behavior function, start function, and then there's the update. So every frame, it's going to run this script and look for the position of your mouse, which controls where the paddle is. And I clamped it to the screen so the paddle can't go off camera. Here's my script for the ball. And it uses the paddle to figure out where the ball is at the start. So it like clamps the ball to the paddle. And the game won't start until you click on the mouse and launches the ball. Right here's my on mouse click. It gives the ball a velocity and makes it where the game is started. And then this is my method where it's locked to the ball or the paddle. Does a lot of math to figure out what position it is and uses the component transform to get those positions, X and Y. Yeah, pretty much it. I wish I had it running. I didn't quite finish it, or else I would play it and show you guys. But yeah.
Why don't you go ahead and bring the Unity up on the screen and show everybody how you got started? Because you have about 5 more minutes.
Yeah, I do.
gonna go fast. Is there Unity here?
Why did you serialize some of the variables on it?
The model be like Unity does that automatically. I mean, I put it as private, and then some reason it was serialized. And I'm very new to Unity. Like I followed a course on Udemy. I don't know if you guys heard of that. Got this on there? No. There we go.
You can just show everybody kind of what it looks like when you create a project. What the interface looks like. No pressure. You don't have to create a project.
Yeah, I was gonna say, I was like, I'm still very new at this. I mean, they have tutorial projects to follow. They have tutorial projects you can download and follow.
They're not fast.
But you gotta start a new project. I just create project real fast. Mine was a 2D game, not 3D, so I should have chose 2D. But I have it on. It's just loading a bunch of stuff. Yeah, I'm really bad with timing presentations. So here's the interface. You have your main camera. This is all 3D. Add what? Sorry.
Add a cube or something.
You have a scene. Scene assets. Yeah. Kind of
It's not showing on this.
game object. Is it not showing?
I was going to tell you what to click, and I'm like, wait, I can't see it.
This is not showing it, or?
Change your. That's all right. You
I'm
can just- so once you got your Unity project,
Yeah.
you just put play up there,
Yeah.
your little play button, and it'll show you your game kind of as you're going.
Yeah, you can add like sprites. You can draw whatever, find whatever online. You can add it. You can create your sprites in the prefab. That way, you don't have to constantly add the script. And like you just copy and paste, and it'll just keep creating that object. So like the multiple blocks. Like yeah.
Give him a hand.
I'm sorry. I wish I had my game ready. There's a lot going on.
There's a lot going on. We have Dave. David's getting up there. I'll make a couple of comments. First of all, facial recognition on my fancy new phone fails with my mask. And when I tried to get it to do facial recognition with my mask on, so that I wouldn't have to be constantly entering my passcode, it rejected me and said, your face is covered or something. It wouldn't do it. So it wouldn't recognize my mask on it. And then the other thing is, don't forget CIS151 next semester. is the OTC game programming class where we use Unity and C#. And the people that have gone through that class have come out of there with a much deeper understanding of object-oriented programming and how C# classes interact, because like Michael was showing you, the whole thing is by its very nature object-oriented. So don't forget about that class when you're scheduling if it's something that you're interested in, because it's a hybrid that meets on Friday. And I have been really surprised at how much it has helped people develop a much deeper level of understanding of programming overall, which is really surprising, but I guess it makes sense since it's all graphical and you can see what happens in your code. Okay, I'm done, David. You got ready fast.
So I just wanted to talk a little bit about writing more secure code in C#. I had this quote, there are over 130 large-scale target data breaches in the US each year. And I saw another quote that said something like each data breach costs a company on average like $5 million. So you really want to, if you're writing software for a company, try and prevent that from happening as much as possible. And to start with that, it's good to know about the vulnerabilities that exist. Obviously, it depends on the application that you're writing, and it's up to the developer to really know and prevent these weaknesses in code. First and foremost, like a lot of these companies have, bigger companies will have whole security teams, but if you can stop a vulnerability from existing in the first place, that's obviously better than leaving it up to someone to find after the fact. So the Open Web Application Security Project, OWASP, puts out this top 10 list of security risks every year or two. And they break down pretty much the top risks, like the top things that are being attacked, and what causes these, and how you can go about fixing them a lot of times. So this is just an example of their list. And what I wanted to talk about was code injection, since we're working in SQL. It's pretty relevant. So year after year in the OWASP top 10, code injection is always there. It just remains a problem. And it's the type of thing that could be pretty easily prevented if you're coding for it. But a lot of people just don't, either through not knowing about it or just wanting to get code out quickly and wanting to have something that works over something that's totally secure. But basically, code injection is just anytime you have like an input field where a user can enter data, it's a possibility of the user entering code that will be interpreted and run. With SQL injection, it's someone running queries through like a username field. So they can, instead of entering their username, run a query that pulls a whole database or runs a drop table, deletes your whole database. And this is what an SQL injection looks like. It's really simple, or it can be. And essentially, you're just taking advantage of the way the code's written and closing the quotes and then starting a new statement. And in this one, they insert a statement that's basically always true. It's just two empty quotes saying empty quotes equals empty quotes. So since that's always true, it'll always return the table that's being requested. And this is another one. They just use a semicolon to end the statement and insert a new statement, drop table employees. So they just delete your whole employee table. So here's an example. W3 Schools has a pretty good page on SQL injection. So this is the way the code is written. They have your username and your password. And then the whole SQL string is just concatenated with the username and password that are entered. And this is the wrong way to do it because it's vulnerable. So they're expecting John Doe and my pass. But if you enter the injection from before, basically what you're doing is closing the quotes for the username and inserting that or statement that's always true. Then after that, they can just write whatever query they want and it'll work. So in C#, it's pretty easy to prevent this if you're coding for it. There's probably several different ways to do it, but an easy one is the in SQL, the SQL client namespace, there's a parameter class, and it lets you separate input and query data. And it also lets you put limits on what inputs are acceptable and what data types everything is going to come out as. So this is an example from the Microsoft documentation on using parameters. And basically, you'll just make these placeholders using an @ symbol and then whatever parameter name you want. And then you can add a whole new parameter with, in this example, they have a restriction put on it. It's always going to be an integer. And so when they enter the SQL command, instead of having just that raw string data, they have that placeholder, which will refer to these parameters and enforce any restrictions that you put on them. And I think that's about it.
Question? Really good, thank you. And then, Kelly.
While he's gonna be thinking about your employee project, is it open to SQL injection, or did you use the parameters? Another thing that's safe, David mentioned there were lots of ways of doing it that are safe, but another way that's safe is by using the stored procedure. If you remember, our textbook had us create that stored procedure, and then later on in the chapter in that project, they could use it. You take a look at that real close. That's the safest way. The parameters, the LSI field. He's ready.
Or if you don't stop laughing, make you pick your own switch.
You ready?
All right, so for my project, I decided to look and see what was new with C#, and Microsoft actually released C# 8.0 a couple months ago. So I looked through it and looked what was new, and a lot of it was way over my head. But they added a new version of the switch, which we all use, the switch statement, which we can use to pick between different paths of code. This is what the switch statement we would write right now would look like. You know, we have our cases and then the variable that we would have to check against, then whatever you want to do, and then a break at the end of it, and then your default at the end. Microsoft apparently thought that this was too much, and they wanted to make it shorter and more concise. So they added the switch expression, which this is the same exact thing. It does the same exact thing, but it's way less code. As you can see, the variable you're checking against now comes before the switch keyword, and the case statement is now replaced with the lambda operator.
And instead of everything being in a statement, it's actually an expression now. And the default has been replaced with the, I can't remember, I think it's the throwaway or throwaway keyword or something like that. It's on the next slide. You can find out. The discard character. Yeah. I had a difficult time trying to code an example of this because you have to have Visual Studio 2019 and it has to be a .NET Core application. And I will code you guys an example here. Wait. I think it's on the wrong screen. All right, here.
Yeah, we all lost it. You showed the wrong screen.
It's on the right one now.
No, you don't see it.
It was on the other screen.
Is it? Oh. Let's go back.
It's back. I think more people are looking at there.
All right. Look on your actual computer, it's not the big screen then. All right. So to make a project that you can actually use C# 8.0 with, you're going to go and use a .NET Core application. Now to do this, you'll have to download the ASP.NET extension onto your Visual Studio 2019. We'll just leave the default name for now. Click the wrong button. There it goes. All right. So I'm going to go ahead and code the switch statement here like we would normally. And what I'm going to do here is set a switch statement that you would pass a number to, and then we'll check to see which number you inputted, and then return a string saying which number you gave it. Not a very useful one. I'm only going to do a couple of these here. So as you can see, that's a lot of code just to have two cases and a default case. But if I go ahead and do it using the expression, and I can actually have the switch expression equal the result, so I don't have to declare the result before the switch. It can be part of the declaration. So to write my 0 case here, all I'm going to do is type 0, my lambda operator. Oh no, is it not liking this? Yeah, looks like it's not using C# 8.0. I won't be able to show you that it works, but I can show you how to type it. And then to split your cases up, I'll use a comma afterwards. And then for your default case, you use an underscore.
Wait, you see that first message down there about currently in preview and unsupported to use preview features. Use the preview language version. Can you click on that? Will it take you to a place where you can turn on that preview language version? You see that message I'm talking about?
Yeah.
It won't take you anywhere.
No, it just takes me to the switch for the line 31.
Right.
Yeah, no, I just don't think that it actually is using.
In the corner there, it's supposed to be 16.3.8.
Yeah, that's probably what we need.
Yeah,
Yeah,
I'm assuming that 0.8 is meaning C# for
Probably.
yeah.
Yeah.
or dot.
He double checked in our field, it's hard to double check.
So it's not going to work, but believe me, it would here. And if I were to put the same number into the statement and the expression, they'd both come out with the same result.
Do you think that's easier to understand or harder?
I think it depends on the situation. Or like something where you're just needing a phrase or something, you need to check something like, especially for what we're talking about, like skills that you're trying to like compare stuff, it'd be useful there. But if you're trying to do something like have like a whole program built in a case, that wouldn't be very good because of the real confusion you have. No clear enter. But for something like that, like you just had to like be passing it like a variable someone entered and you wanted to check it, you could do that. Would be really nice for it. So then you would have to have a whole bunch of breaks and stuff clogging everything up. But if you need any math or anything like that, or you just logic inside of it,
So no other great stuff?
Yes.
So
C#
I'm guessing
There's a lot of other stuff. They did a lot of stuff with patterns. In my research of the expression, they wanted to match patterns. That was their big deal with it. And
Okay.
yeah, and they also, and like whenever I researched the original switch statement, that was also a big thing with pattern matching. It was like whenever you inputted your initial variable, they called that the initial pattern.
Next week, we'll be doing regex, which is pattern matching. So I bet that's going to be something that's really impactful.
Yeah.
Okay.
Yes.
I'm guessing we can obviously use the
Yep. Give him a hand. Give him a hand.
Yes, you can still use the old one. Yeah, no, this is just like a little bit of a shorter way, more concise. I guess Microsoft just didn't like the look of the old one.
their workers just didn't want to deal with it.
Yeah. I kind of remember there was a way you could see which version you were using. Yeah, it's not giving me an option for 8.0. Yeah.
Is this 2019?
Yeah, this is on Visual Studio 2019.
Okay, Cohen would like to go.
Nobody else cares.
If nobody else cares, before we're out of time.
No.
Anybody else care?
Let's see the sucker works. Yeah, I clicked on it. Yeah. Back. Okay, cool. Okay, so all right. Are you ready?
No, not yet. Okay.
There's a laser pointer. So okay. Okay, so I'm talking about machine learning, but specifically there's a certain game called Mastermind. Do you guys know what Mastermind is? Does anybody, the board game? Have I heard of it? No, not the cartoon. But so what Mastermind is
this is a long definition if you want to read it. But basically what it is there's two players. Each player, one player creates a code, it's 4 colors, and there's different versions. Some of them have 7 options of colors to choose from in your 4 colors. Some have 10, some have like 6. But anyways, you make a color combination, and the person has to guess the color. The code breaker has to guess that color combination. Most of them have 10 attempts, and what you do is you put in your 4 colors, and then there's 4 little slots on the side of it. Like, here, I'll show you the next. So you'll put in your 4 colors of your guess. Oh, don't touch the board. But basically, and I've seen different iterations of like the pegs, but basically what the pegs are saying, there's 4 holes for each row, is saying white is you have a color right, but it's in the wrong spot. Red means you have a color right in the right spot. So that's your information you use to guess. So like the first one, right, he has a color right, but it's on the right spot. The second one, he gets one of the right spot, one also of the right color in the wrong spot. And so you go slowly until you get to the code. You just use the information. And so you're probably starting to get an idea how you could use that information to teach a machine how to play the game. So this is a little explanation. I won't cover too much. We've had tons of people talk about machine learning. So you guys all kind of know this is just a long definition of it. So, but you guys all get the picture by now. So, but the main thing we're going to focus on this is inference and patterns of the machine, what machine learning can do. And instead of using like an ML thing, I thought it'd be fun to kind of write your own thing. So the plan, and I kind of explained it a little bit, but is to have both sides be played by computer. And you can turn off one side, turn on another side, right? Like if you want to play as the code maker, you could just not implement the code maker side. Flip that around, you could play the breaker and have them make the code for you. But the goal is where they'll both be able to play against each other. Therefore, in theory, they would be learning how to play it better. But every time they play, they can adapt to the information given, because it's not just the information they have stored. The information on the board is relative to the guess. So it updates as the game goes. And the reason using C# for this, other than being like the best language, is that the way objects are built, you can really, I thought I would go into make my own learning, not use ML. I looked into that and I was like, oh, this would be fun to make. This is something simple enough. I think you can make your own program. But you can manipulate objects in a different way than other languages. And also it's really easy to make a GUI. GUIs are really easy to make. And just make a simple, easy, clean one that's not like super complicated, but still pretty nice to look at and still gets the point across. So first thing we need to do is make the board. And the board's going to be kind of like I guess like the controller in this sense. So like it will hold all the data, like the board, how many guesses they have, what their guesses are, how many each guest got right, and that will keep track of everything. And you can expand how many guesses they have depending on how the game. Like if you want to do a short game, do 4 guesses, which is really hard, but you have a quick game. And then they'll also be the parent class to the code maker, because the code maker needs more information than the code breaker. And we'll get to that why. See how many guesses they have left and stuff like that. And it'll also keep track of previous guesses and comparing them for the code breaker. And so I'll talk about why that needs to be that way. But it also will be how things will be passed to a save file that will hold all the information that's learned. Because there are 1,296 options of codes that can be made depending in your regular, I believe it's 8 different colors you can choose from. And so we're going to be keeping track of all of those. And we're going to be keeping track of which % chance they are to be guessed and what % chance they are to be the actual code. So, and they'll be kept track in a different variables, but only relative to each one, right? Like the code maker won't see how likely it is to be the code. It doesn't care. It only cares about how likely it is to be guessed. So it wants to make the hardest code possible. So after we get that all set up, we'll make the code maker, because you can't break a code without a code, right? So it will have all the info of the board, like I said. So it will have how many guesses they've had. So it will know what it's trying to guess, so that it can learn how to do it. It can learn in the game, even though it can't make the game any harder. It will learn how it's guessing for next time it can guess or put a harder code. And when we're doing testing for this, the thing is, like this last line here, every new person will have a better chance of winning because every time you play it, a new person being a new version of the code breaker or actual human being, because it won't have known its style, because everybody will have a style of guessing. They'll go, okay, like you might guess red, white, blue, green. Someone else might always guess the inverse of that. So everyone can have a better chance of guessing because it's going to make a code that's hard specific to the last person it played or the last percentage of people it's played, because it's going to hold on to the data. And you can hold on to it, I didn't explain that, I guess, through an XML file or anything, however you want to. You can do an XML file, probably the easiest because you can create objects in there. But after that, we're going to make the code breaker. So this is where it gets really complicated because the code breaker has to look at basically every possibility. But what it can do is it can, what we can do in a way is set up a variable in each one to check its percentage chance that it was the actual code, and that we can update live every time it guesses. So like if it guesses a specific code and it's wrong, that chance will go down for the next time. And so every time it can update it. And then also it will use the data from the board because the board gives us clues. So it will first decide what is the highest default chance, right? So the first guess will just be basically a wild guess based off previous knowledge. So it will say this specific code has a 60% chance to be the code. It will guess that. Then it can, in the next guess, it will have information from the board. It will say, oh, 2 of these were right, or none of these were right. So then again, it's still just a wild guess. But say one of the numbers is right, or one of the colors in the right position is right. So it can use that to affect the next guess it has. But first it will calculate just the generic guess and then compare that to the info it's learned to the board so that it will get the most specific guess it can. And in theory, guess the least likely one, and then just repeat that till it hopefully get the guesses right or runs out of guesses. But then the last thing, I kind of touched on it a little bit, but I've called it the brain. But basically this is the file that will hold all of it. And this will hold every possible code that could ever be guessed, so that every time it runs, and this won't be the fastest thing in the world, but I'm going more for, I guess, accuracy, like in its guesses, like, but as it learns, I guess it would get faster. You could get it to be faster if you did it right. But it's basically just going to have the code chance of it being the code, and then how likely the code breaker is to guess it for the code maker, which this gets a little confusing in verbiage here. But basically it will hold just all the info for each guess or each code. So I think that's it. I think that's probably like way too fast, and I have a question slide. So questions.
Where did we want to play it?
I didn't. This is something I was gonna do as a after-school project with a friend, but it just turned out to be yeah.
Plan. I like it.
Yeah, it just life got in the way there in that one, but yeah, it's something we looked into doing hexapon first, but we were like, okay, hexapon seems too simple. We want something like hexapon seems like something we could do in a couple weeks, so we wanted something difficult, and this seemed like a fun game to where you could build it and like you could first build the game and play both sides, right? That's where you would start with, is you just build, and I kind of was working there a little bit of assumption that the games itself was already built. That's a different than machine learning. That can be done really in any language with pretty easy. So that was my assumption, I guess, going into this, that we already have a functioning game. You can play as both sides of the human or the maker or the breaker. So, but that would be, you'd set that up, and then you could start making the code maker to where it keeps track of your guesses, and then you have in theory, a harder and harder opponent each time you play it. So, and then so forth, and make the code breaker and so forth.
Have you tried on YouTube if there's anything that's similar
Like hexapon is a very similar one. So there's I think it's I can't think of the name of the video, but they show how you can use beads and matchboxes to make a machine learning computer, a physical machine, like you manually do it, and it's through hexapon. So hexapon is like chess kind of, but it's a 3x3 board, and so the rules are really simple. Basically, if a piece gets across to your side, you lose. If it gets in a deadlock, it's stale, like nobody can move. or if you have the opponent has no pieces left, you win, and vice versa. So you move forward one piece, they all automatically have a counter attack because it's 3 by 3. So you move the center one, they have 2 counter attacks, so forth. So it's really easy to. There's only about, I think, 12 max moves if you do it right. So that's 12 matchboxes that you have, and it's really easy to make the thing learn. And so that we thought that'd be really simple to get basically make a computer that would always make the right move, even unless you threw it off specifically. And so we thought this would be a little bit harder because there's 1,296 combos.
On like a smaller scale, could you like tic-tac-toe?
Yeah, we thought about tic-tac-toe as well. Again, with tic-tac-toe, there's not as many options. And we thought this one, and then also tic-tac-toe, you have to keep track of, there's the thing we thought about there is both sides have to be keeping track of all the same information. So it's a little bit more complicated that for it. You get easier results, but you have to keep track of more. This way, the code breaker is only one has to keep track of a lot. The code maker just goes, oh, here's the code. And yes, it's learning as it goes, but during the game, you have to keep track of it. That was the thought process there.
I like
And Mastermind's a really fun game. I played as a kid, so that's has a little bit of, and it's code, right? You're making codes. But yeah, this is more of like a, I guess, theory presentation of like how I would go about making it. Like, I mean.
Well, that's good because that makes it easier for you to take as an assignment.
But yeah, this would be quite, I think, an endeavor just because like you'd have to manually, I guess you could write a program to manually write out your XML file. I think XML would be the best way because you could have, you could have it sorted by color so that it can also give a color, like each slot has the highest color chance. For like the first slot, you could do it by slots of color. You could do the first slot, black is the highest. And you could rewrite it each time to be where the highest chance is the first thing. So as it goes through, it looks only at that and it goes to the highest chance so it doesn't have to run as long. That's a lot harder, but you could do it that way. Or you could just have it all slapped on there in whatever order you want and then have to look through everything. But
Good, I like it. Go in my hands. We are fine. You guys fed right through all our time. So next time we have just about the same number, hopefully. We'll get everybody a chance to finish. So have a great day. I'll see you on Wednesday.
yeah, we were going to write Python is what our original, because we want to use Raspberry Pi to basically, we wanted to do like we made a whole controller and
Oh, cool. I see. Mm-hmm.
Yeah, and so that was why we chose just because it's
Yeah, you could
faster.
use the little. Mhm.
But if you're wanting to just do like a form basically,
Uh-huh.
which that's what I was talking about using Weekly for simplification, you can really make it easy.
Well, I'm trying to think that our final is a Jeopardy game. So I almost think you could do that game instead if you wanted to, but I don't know about your AI part.
Yeah, the game wouldn't be, I don't think the game would be super complicated.
But the
what you can
AI
do is
part.
Just an array of objects.